All right. So welcome to lecture 10. Last time we stopped at this point where we were looking at ways of writing and reading files, opening files, closing files, putting information in files for permanent storage and that kind of thing. So that was the last thing we discussed. I'd like to then go now into a little more the advanced graphics. When we now going to manipulate more complex images, if you will, not just plotting images, but manipulating or ways of manipulating images. So, but before we do that, let me start by looking at this command, the G input command. MATLAB offers a way for entering ordered pairs of X and Y values that you can do graphically. The G input command is the one that allows you to select points from a figure and then see what those points correspond to in the image or in the figure. So the format is you call the G input command and you request for n number of points that you can select in the figure window, and the values you select, which are interactively selected, are put into this XY array. And the other command is to use it without the parameter n, and in that way, MATLAB assesses points until you hit the return key. So on this one, you will then, and you'll see how that works in the next example, in the next figure, because it's very useful for just picking up graph in a point, points in a graph rather. In this, again, repeating the format, when you call the G input command, if you give it an n number, 2, 3, 4, whatever that is, an integer number, you telling MATLAB that you're going to select n number of points in the graph, okay? And MATLAB in return will return those values into this array. If you don't tell MATLAB that you're going to enter a number of points, then you can keep selecting points until you hit the return key. Once you hit the return key, then MATLAB understands that you're done, and at that point you can finish, and MATLAB will put the results again into the XY array. So let's see how this works. So I created this little function here that shows this square function to show you the uses of G input. So if I'm going to use it first with an argument 2, meaning that it's going to allow me to select 2 points. some of the more advanced graphics now. We're going to start by looking at the image SC function. MATLAB allows you to manipulate images, a little more advanced images. And one of those commands or functions is the image SC function. It stands for image scale, and it uses a color map to represent the data. It's a little different than looking at it from just the three-dimensional point of view. It gives you another point of view to look at the image. It will linearly scale the data so that you can see the full range of the image. So in this example, I've created the peaks function. And as you notice here, I moved it up 10 units up on the z-axis, which is this command here, right? So doing this first part it just moves this. When I hit surf, you can just see that three-dimensional image being pushed up by 10 units, and that way I have room at the bottom to then display the same image, but this time using the image scale function. And as you can see, what the image scale function does is it maps the different valleys and heights of the image into some kind of color at the bottom here, right? So it's just another way of looking at the information. Let's look at another example of the same. On this one, I'm loading the spine function, or I'm sorry, the spine image. This image, by the way, is a built-in image in MATLAB. You can, it comes with a program, but it shows you, an interesting image that you can use. The intensity information, when I load this image, load spine, which is the name of the image, it's going to place the intensity information on a matrix in a matrix X, okay, by default. So loading the image, when you try this on your own, if you look in the workspace, you're going to see a rather large X matrix. And that's the one that has the information on the intensity of the image itself. So if I use image scale X, it displays the image, and using this color map with the parameter bone, it chooses the color scheme that the image will show. In this case, bone, it shows you the different grayscale levels. Okay. So this color map here controls the scheme for the image, the color scheme you're going to see. Another example, again, one of the several images that come with MATLAB that you can simply load. I'm loading this clown image. Again, I'm using image SC to look at the image, and if I use the color map, it creates the default mapping of what the image looks like in color. If I want to see it in gray, I can just change the color map to gray, and you'll see the image in gray. There are several other schemes that you can use to see images in different shades and different colors. But again, the way you manipulate that is by using the color map command. So each of these images, again, creates a matrix of index value that is called X. And you can then create a color map that you can use to look at different shades or different colors of the same image. The other things you can do also to manipulate the images. For example, here I loaded this image Earth. Again, another example of an image that comes with MATLAB. By using the image SC command, I'm simply asking MATLAB to display the information that is included in this matrix X. And I'm using the color map, which will give me this color image. And as you can see here, it's kind of flat, right? So one of the things that I can do to make it look more like a circle, although Earth is pretty much more like this, but we used to see it more like this, right? So what I can do is, following the same commands, I can use the axis image. And what the axis image does is it fixes the aspect ratio, right? So it makes it into, same size on both axes. And then if I use the axis off command, I will remove these numbers from the image. So it's just another way of manipulating images for different purposes. Okay. All right. So now we're going to talk about reading and writing files, image files. And to create a MATLAB matrix from a file, we use the image read function, imRead, and assign the results to a variable name that you choose. It can be used for this command imRead, or the function imRead can be used for most of the standard images formats such as PNG, JPEG, or TIFF, or many other ones are the common ones. So if the file is a .mat file or a period .file, the easiest way to import the data is to use the load function as we used before. The .mat format is specific to MATLAB, can be used to save any kind of data. And to write to a mat file, we use the save command. So again, if you want to import data, we use the load command. And if you want to save it, we're going to use the save command, and it saves it to a mat file. To import data into the MATLAB workspace, excuse me, from a graphics file, we will use the imRead function. And to display the image, we will use the imShow function. Okay. If you have a file in the standard graphics format, like a JPEG or a TIFF file, use the iminfo function, and you will get information about the contents. So we're going to apply all those images functions to see how they can be used to manipulate images. So we're going to look at the ones we just mentioned, like imShow, read, and iminfo. Okay, so let's see how this works with some of the images now. I have this image here that I'm using the imRead command to read the image. In this case, it's a JPEG image, and it's located in my local file. This is not a one generated by MATLAB, by the way. This is on my local path, and so I am using the imRead command to read the image, and I'm placing the information into this matrix I, and I'm using the imShow command to show the contents of I. Okay, so a little different than the load command when you load the image, right? And here I'm reading the image, placing it in the file I, and I'm showing how the image looks like by looking at this imShow function. Okay, so it's simple, right? You read the image, you display the image that way. Now, to look at a little bit more information now, I'm using the imhist command. And what the imhist command is going to show me the pixel intensities, and it's going to show me the distribution of the pixel intensities. So since we're using an 8-bit image, it's representing the images in 256 levels from 0 to 255, where 0 represents black and 255 will represent pure white. So if you were to use, and this is of course using integer values, right, from 0 to 255, shows me how the pixels are distributed for that image. If I was to normalize this, or in other words, make it from 0 to 1, I will see the same information where 0 will represent black and 1 will represent pure white. And that's used when we use like double numbers instead of integers. So this shows you something that we'll look into in just a little bit, how the color information is distributed for an image based on these numbers from 0 to 255 or from 0 to 1. Okay. But again, looking at this image again, it'll show you that there's some black content and there's some real white content on the other end. But most of the image really intensity is located right here in the middle, right? Somewhere in the middle, especially in this area right here, right? Which it doesn't make the image good or bad. It's just giving you information about where the intensity of the pixels are located. But if you wanted to do something like manipulate the image, manipulate the pixel, you can do, for instance, if we use the, we're going to use the HISTEQ function, the HISTEQ function, which what we'll do is we'll equalize the values of the pixels to try to make them distribute a little more evenly. So if you look on the left-hand side here, I'm using the same commands I used before. I'm reading the image. I'm showing the image, displaying it with the IMShow command. And yeah, I'm just holding that image as this figure here. Then I'm calling the HISTEQ function. I'm passing the image information, which is I, and I'm creating a new matrix called I2. That matrix I2 now has the histogram information, but this time it used the HISTEQ command or function to normalize or to equalize the values of the pixel. And I'm showing that again using I2, okay? So if you look at the previous slide, right, this is the original image with the information, a lot of the pixel intensity information somewhere in the middle here. But now I just use the HISTEQ command, EQ command or function, and see what happens. The information now is more, you know, average, if you will, more equally distributed almost. And as you can see now, that changes how the image looks like now, right? Because now, you know, there's more black information, there's more white information, and, you know, doesn't matter at this point whether the image looks better than before or worse than before. All we're trying to show you is how you will then manipulate images by applying functions like this. On this second part of the script here, I basically just repeated what I had on the left-hand side, but the only thing I want to show you is that if I want to save the image, right? So I'm showing the image like before, but now I'm going to save it because now I apply the equalizer command, and it created a new image that looks different from the previous one, right? And what I'm doing now is I'm just saving. I'm using the IMWrite function to save the image. This is the image I have, I2, the one I created based on the HISTEQ. And I'm saving it in a new file that I'm calling engr2.png. Okay. And as you notice also, I can change the formatting, right? The previous one was a JPEG image. Now I'm saving it as a PNG image with a new, the new extension. So you don't have to save it as a PNG. You can save it as any of the formats that this function supports. So, okay, that's one way again of manipulating images using, something simple like the HISTEQ function and saving the image to a file. Okay, now we're going to look at, obviously, if you remember, the context of what I'm going to talk about now is that when we plot images, if you remember, and I'm talking about two-dimensional images that we plot, well, not just two-dimensional, even three-dimensional, but I'm going to focus on two-dimensionals, that we can place information about the image or the plot on the figure itself. We can label the axis, we can create a title for the image, And we can do all sorts of things by using commands directly when we're plotting the image. Different commands, right? Like the title, the axis, the y-axis, and all the other commands. Well, there's another way of doing that by or creating, manipulating information about a figure or a plot by using a different approach. And this approach uses what is called handles. Um, MATLAB creates a figure like a container and then says the axis and then the plot on the top. In other words, what it does is MATLAB creates, in this case, three different what's called containers. One for the figure, one just for the axis, and on top of those two, it places the actual plot. Okay. And when you use a plot function, either from the command window or from an M-file program, MATLAB automatically creates a figure and places the axis information. So it creates the figure, the container, it creates the axis, places the axis information, and then draws the plot on top of those two other containers, if you will. But when you just do a plot generically, MATLAB uses default values for many of the plotted properties that you have. For example, if you just do a plot without changing anything on the plot, like plot x, y, by default, the line is always going to be blue. That's a default value, right? So, but if you want to change that information, as you remember, we can use commands that will change the color of the plot itself, the line, or we can use what I referred to as before as handles. Handle is a nickname given to an object in MATLAB. Okay, MATLAB uses, like I said, a hierarchy system for creating the images. First is the figure, then the axis, and then on top of that, we'll create the plot. And it handles each of those areas, if you will, separately. So you can access that information separately. So let's say how we do that. So in this case, I have a plot of a simple cosine function, and I'm going to use some of the plot handles to put information on the plot itself. So assigning the plot a name is called a handle. It's going to allow us to easily ask MATLAB to list the plotted object's properties. So for example here, first I'm going to clear everything I have. I'm creating an x-axis equally spaced from -10 to 10, as you can see here. And then I create the cosine function. And I'm going to plot it just as before, but this time I'm going to give it a name. I'm going to give the plot a nickname or a handle name. In this case, I'm going to call it H. It could be any variable that is, legal within MATLAB. But in this case, I'm going to call it H, right? And I'm going to create a title for it, like we had done before. And this time I'm going to call it trigonometric function plot. As you can see here, I'm going to also label the x-axis and the y-axis, right? So this is what we've done before, right? With commands like this, I can put information into the specific areas that I want, the axis, the title, and so forth. Now let's see how we use this H, the number I gave, the name I gave to the plot, to recreate the same result. At this time, remember, the variable H is the handle for the plot, okay? And again, we could have chosen any other name, any other variable name. It is listed in the workspace window, if you look at it, as a matlab.graphics.chart, that primitive, that line. You can check it if you run something like this in your workspace. And stores all the properties of that line. So this H variable will then have all the properties associated with this plot. So since we didn't suppress the output with a semicolon, when the code is executed in this case, it returns a list of the plot properties. So it will return this with the handle or the nickname H. As you can see, it has a list of all the properties associated with this plot, right? The line style, the markers that are being used, the marker size, and so forth. The color, right? And this list is partial, by the way. If you run this in the command window, you'll see this information, and there'll be another link that'll say show all properties. If you click on that link, it'll show even more properties associated with this plot. Okay, so what we can do then now is choose of all those properties based on the name that I gave the plot. I can choose whatever property I have related to the plot and make a change. Okay, instead of using commands like before. So what we do is, in this same example, I use the plot handle H. The plot handle H refers to the line drawn on the axis, which is different from the axis or from the figure window. Remember, there's three different things that the plot is handled: the figure, the axis, and the plot itself. So the one I'm using just now, the H equal plot XY, is referring to this line here that's going to be drawn, not the axes themselves or the figure itself. We're going to deal with those two a little later. So by just using the H equal plot XY, X comma Y, I'm just dealing with this lines or line that are going to be drawn on top of the axis, okay? So, so again, I'm just dealing with that part of the overall plot. So if I want to change the line color to red, I will use the plot handle, which is H, or the name I gave to the plot, and then the property I want to change. In this case, I want to change the property color, and I'm going to assign that object of the handle a red value. Okay, so this will make the color red. If I want to change the line width, let me show you again from the previous one. You see how the properties include the line width, the color, and so forth, right? So I'm using the dot H dot property, right? H dot color, H dot line width in this case, and I'm gonna make it equal to 3. I can do other things. The marker, so we'll do H dot marker or H dot line style, which is here, right? So by changing that, see, I'm going directly into the objects that manipulate that the line that is being drawn and accessing that by using this dot formatting with the name of the plot associated with the property of the plot. Okay, so let's see this. So notice that we're changing the properties of the plot by using this dot notation. So I'm going to repeat, replot the figure again and show you some of the options here. So look at the plot. Okay. And so one of the nice things about this dot notation is that if I use the name of the handle that I gave the plot, and I gave the plot a handle named H. So if I type H dot and then tab, it shows me all the, all the options that I have, and I don't have to retype any of it. So for example, if I want to change the color, I just double click on the color and, assign a color to it. If I want to do green, and then if you look at the plot, then it's going to be green because I changed it, on the spot. Can do it again, H dot tab, and it will show me the, the option that I have to change whatever I want. So it's easier to do it that way because you don't have to remember all the different names, you know, specific to what you want to change, like line width. Double click on it, and I just enter again a number. In this case, I'm going to enter 3, and then if you look at the plot, it has to make a change, right? Now, another thing also here is that if you look on the right-hand side on the workspace here, the variables, you have the name of the plot, the handle page. So if you double click on it here, you get another menu, as you can see. And you can also change things on the spot. Like the color again, I can just choose it. The line style, again, I can just choose it. The line width, and so forth, right? So you have another option here. And again, you get to this menu by double clicking on in the workspace the name of the plot handle. Okay, so we look how that can be easily done by manipulating the properties, if knowing the name that we give to the plot. And so that's one of the 3 areas that we were looking at, right? We remember we said that MATLAB first creates a container that is called a figure. And on top of the figure, it puts axis, and then on top of the axis is going to draw the actual line for the plot. So we saw just now how we can manipulate the actual line that is drawn for the plot. Now we're going to look at how the figure itself can be handled, the figure information or the figure characteristics. Okay. So we can also specify an object name or handle for the figure window. Since we drew the graph in the figure window named figure 1, then we will use this command f handle figure, and we assign that figure to this f handle name here. Right? So now the figure that we created in the previous example can be accessed by calling this f handle name. And as you can see now, if we look at the properties of the f handle, and this shows you again a partial list of properties. If you want to see all properties, we can click on show properties, and it'll display even more properties. But the more useful ones, if you will, are shown here, like the number of the figure, the name of the figure, which you haven't given a name, the color, the position, and the units. Okay. By the way, you see in color here, you see 3 numbers. We'll see later how those 3 numbers relate to the specific color RGB, red, green, blue, okay? Because if you remember, RGB colors can then be used to create any color. Okay? But we'll look into that a little more later in more detail. But just remember that those 3 numbers are associated with red, green, and blue for the specific pixel information. In any case, the handle now name for the figure is f underscore handle in this case. Again, I just gave it that name, right? So we changed the plot properties previously through the plot handle. Now we can change the figure property through the property handles. And let's see how it's done. Okay. Again, if you haven't specified a handle name like this, right? If you haven't specified a handle name, we can ask MATLAB to determine the current figure with the command get current figure, GCF. This GCF command, if I use it with the get function, get GCF, which again is get the current figure information, will show me all the properties associated with the figure, the current figure. Okay. So that's another way of getting, either you give it a name like here, the handle will be f underscore handle for that figure, or you can use the get function and use the get um, uh, GCF command, get current figure information, and it'll display the current figure information. Okay. And so now for handles, right? We then look at how we can manipulate the handles. I'm sorry, the figure with the different properties, the plot with the different properties. For the axis is a similar process. Okay, just as we can assign an object name to the figure window and the plot itself, we can also assign an object name or handle to the axis by using, in this case, we're going to use the get current axis information. Okay, so this time we're going to use the GCA, get current axis information, and I'm going to display that information and put it into the h underscore axis variable. So if you look at that contents of that variable, it'll have the different properties associated with the axes. Okay, as you can see here. So just as with the plot handle and the figure handle, we can use the axis handle to change those properties. This is, again, particularly useful if you want to create custom axis labels. So let's look at how this works. Remember that using handles is just another option that you have for accessing the properties of the plot. The way that we've been using this before is just to, if you want to add something to the plot, you just type it and say, for instance, title cosine in this case, right? I can, add a label, X label, for instance, and it'll show up with the X label in this case. So this is what we've been doing so far by adding the properties individually if we want. Now the idea with handles is just another way of getting to these properties, right? So going back to our way of getting the figure information, right? For example, we have all the properties here, and we can, as we did with the plot itself, if I type F handle and period, and again the tab, it'll show me the options again. And I can change options here, or properties, as you're saying, by selecting what I want to change, right? So that's one way. Another way is, you notice here that we also have created a handle for the figure. size using the dot command, there's another way of getting to the properties. And this is one method that eventually I think MATLAB is going to get rid of because it's dealing or is heading more towards using the dot um, commands more specifically. But there's also a way of getting to the properties by using the set command, which is also very easy to use. And the set command can be used like in this way, right? You have the information about the handle that you want to change. In this case, if I said set, the command will expect the name of the handle that I want to change. In this case, if I keep with the previous example, if I use age, it refers to my actual plot. So I want to change color and I want to make it red. So this will change the color to red. It's the same as doing it with the dot command, age.color equals red. So these two are equivalent, okay? Same thing if I do the handle, and if I use the dot command, right, directly, dot color, if underscore handle that color, I can change the color here, right? The red, green, and blue to the specific numbers. Or if I use the set command, I can do it again. If I use the set command parentheses, the name of the handle I want to change, the property I want to change, followed by, what I want to change it to. Okay? So you can see that they're very similar, right? The one uses the dot property command and the other one doesn't, but it uses the set command name. One more, if I want to change the handle name to my graph, right? Using the dot command, I will use the handle name, the property associated with the handle, in this case is name, and I will change it to my graph. If I use the set command, it's the same as before, and we'll call the name or the handle name of what I want to change, the property I want to change, which is name, and the information to what I want to change it to. Okay, so this is another way. Again, this is a set command is something that MATLAB is may get rid of later, but it's still being used in many textbooks. So we're going to continue with a way of manipulating images, but we're going to start by talking about how MATLAB sees colors in a way. We're going to start with a grayscale. So what is a grayscale image? Well, a grayscale image is a two-dimensional array which has a certain number of rows and columns. In each location of that array, we're going to have a number associated with a color. Each location is called a pixel. And as you probably know, a pixel means a picture element. So that number, that pixel number, identifies the intensity of the image at that specific location. A high value means that you're going to see a brighter display or value at that location. So a grayscale image is represented by 256 levels. The reason is that we use 8 bits to represent these numbers. So 2 to the 8 is 256 levels of gray, from 0 to 255, where 0 represents black and 255 represents pure white. So 0, pure black, 255, pure white. Anything in between is it's going to be some level of gray in the figure. In MATLAB, grayscale images are represented by numbers between 0 and 1. Okay? So if the numbers are double, from 0 and 1, I'm sorry, if the numbers are double. If the numbers are of unsigned integer type, then they are actually represented by numbers between 0 and 255. So let me repeat that. If the numbers are doubled, you're going to see from 0 to 1. But if we represent the numbers as unsigned integers, then we're going to use 0 to 255. Again, the lower you go in the scale, the darker the pixel is. And the higher you go, the lighter it is, from black to white. Okay, so let's look at some examples here. So how we can manipulate those grayscale images here. I created a little script here. I'm going to start with, if you look at the first element of the script, I'm going to create a grayscale images of size 200 by 200 pixels that includes random numbers. And so you initiate the matrix as a random 200 by 200 matrix, and we're going to display the values created using the IMShow command and see how that looks like. Okay. Now the second image I'm going to create. So the first one again is just a 200 by 200 pixel image with random numbers from 200 to 200 that will show you a grayscale. Okay? And then in the second example here, the second figure is the same idea, displaying random numbers, but this time we're going to half the size of the image, and we'll see how it looks like. On the third image we're going to create, we're going to have a grayscale image, and this time again is size 20 by 20, and we'll have a gray horizontal lines every 4 rows. And so you can start that at 0 with an array of zeros of size 20 by 20. So that means that, you know, since there are zeros, right, we're initiating that matrix of zeros, then the image is just going to have black because 0 represents black. But then every 4th row, we're going to assign a number 0.5, which puts it in the dark grayscale. Okay, almost in the middle of the scale actually, because you can remember you go from 0 to 1 when we assign double number here. And then we're going to show that again in the figure. The fourth figure I'm going to write is a grayscale image again of size 20 by 20. But this time we're going to have a bright background, not white. And it's going to have a gray square of size 5 by 5 in the middle. So again, this is a 20 by 20 pixel size image. But this time, as you notice here, we're going to create a matrix of ones, and once again being white. And we're going to multiply by 0.8 to make it a little less white, if you will. And multiply by 0.8. And then in the center of that image, from rows 8 to column 12, from rows 8, 12 to 12, and columns 8 to 12, which is the center of that image, we're going to change that color to 0.5. So we're going to make it gray, kind of gray again. Okay. And the last image I'm going to create is, again, an image of size 200 by 200. And I want to have a dark background with a white square in the middle. And so it's basically the opposite of the fourth image, except that it's larger, right? So again, on the fifth image, I'm going to have a grayscale image of size 200 by 200. I'm going to make the background completely dark, then I'm going to insert a white square in the middle. So again, I'm going to start the matrix as a 200 by 200 matrix of zeros, which will initiate a complete black image, right, of 200 by 200. But then in the middle of it, every, from 50 to 150 row and from 50 to 150 column, I'm going to make that number of 1, or that pixel of 1, meaning that it's a complete pure white. And I'm going to show it again. All right, so this is what we'll do. So we're going to start with the first image, which is a 200 by 200 with random numbers. and then we're going to show it. Run that. Okay. So that's a great image, right? And since it's random, you see, numbers from 0 to 1 all around that image, right? So you see what it creates. Okay, that's the first figure here. And then for the second one, it's the same image, right? This is the second one here. Move that out of the way. Right, which is the same as the first one here, said that it's just half the size, right? It's just half the size of the previous one. Is still a random matrix, and I'm just displaying the random numbers here. Okay, and then on the third one here, which is a very small one because it's just 20 by 20 pixel size. And start with that. Take a little bit. Let's see. Yeah, I'll bring it again. Let's look at the next one. The next one is a grayscale image also. This is figure 4, which is simply a very small image again, 20 by 20 with a bright background, not exactly white, because I multiplied, remember I created a matrix of ones, 20 by 20, ones being black, but I multiply by 0.8, so I make it a little, I'm sorry, 1 being white, and I multiply by 0.8, so it becomes a little gray, not completely white, and then in the middle of it, for the 5 by 5 square here, I created, I inserted a 0.5, which is about the middle of the range from 0 to 1, so it makes it a little darker in the middle. And then for the last one, okay, again, and run it. So now I have, again, a completely black background, right, by this statement, by this matrix here, zeros. Is all zeros, 200 by 200, which 0 means black, completely black image. But then in the middle of it, I'm going to insert from rows 50 to 150 and columns 50 to 150. I'm going to make that color for that pixel 1, which makes it all white. So you end up with a middle white square in the dark background. Let me run this again because we skipped figure 3 to show you one more time. All right, so that's our first image again, a 200 by 200 random, which gives you, all the levels of gray here in this 200 by 200 pixel image. Same image, but just half the size. And then this is the third one, which created again. You look at the third figure here, which is this one. It's a grayscale image again of size 20 by 20, very small. But we're introducing sort of whitish horizontal lines in between the dark image. So we initiate the matrix as zeros again, just a black square 20 by 20, and then from every fourth line, okay, we're introducing we're changing the pixel color of intensity to half. So that makes it not exactly white, but sort of dark gray between those darker segments here. Okay. And so we have the other one again, just the sort of the reverse is still 20 by 20, but this time we created a center which is a little darker than the image around it. And then the last one again, which will have the center white with the background completely dark. So we just discussed grayscale images, which are basically two-dimensional. And we talked about, black being 0 and white being 1, and manipulating the different numbers from 0 to 1 will give us different values of different colors of a grayscale from black to white. So in the case of grayscale images, like I said, the two-dimensional images that can be handled with two-dimensional matrices. When we look into color images, then we move on to a little more complex set of matrices, because now we have to deal with three-dimensional color. Now it's represented by three-dimensional matrices, so pixels in this case, where each pixel represents a coordinate with either associated with red, green, or blue. As you probably remember, as we mix those values of red, green, and blue, you can create different colors. So bottom line is that to represent color images, we need to deal with three-dimensional matrices, not two-dimensional matrices. So just to give you a little bit of review of how we can manipulate some of those matrices and put values in it that we're going to need. Let me go back to a simple two-dimensional matrix. And this time, I'm just going to create a 5 by 5 matrix of zeros. Okay? That's all I'm going to do. So that gives me, as you remember, just a simple 5 by 5 matrix of zeros, right? Two-dimensional matrix. If I want to put numbers in that matrix, then it's easy, right? If I want to, for example, say I want to have the third column, I want to fill that with just the number 2, right? So I'm going to look at all the rows, but the third column, I want to have a 2 in each of those columns. Something you can do very simple like that, right? Now let's say, let me just reset this value to start with scratch. So now I have zeros again for my original 2 by 2 matrix of 5 by 5 matrix of 0. And now I'm just going to put 2's and locations from row 3 to row 4, intersecting with column 3 to column 4, right? So obviously, row like this, that's very easy to do. Just go from row 3 to 4, and then from column 3 to 4, and I want to have inserted those locations. So if I do that, then, as you can see, now I have my matrix with 2's in those particular locations, right? The third row, fourth row, intersecting with the third column, fourth column, right? So I use that command here in order to do that, right? Some other things that you can do, of course, is manipulating the rows and the columns. You can insert those numbers or those values in specific locations that you want. But look at 3 dimensions, a little different now, because again, you're dealing with 2 dimensions, you deal with 1 matrix, and when you go into 3 dimensions, you deal with 3 matrices. So to see that, I'm going to generate a 5 by 5 of zeros, but this time it's a 3-dimensional matrix. So I have 3 matrices. I have matrix 1 with zeros, like if you represent the x-axis, matrix 2 with zeros, maybe representing the y-axis, and matrix 3 with zeros, maybe representing the z-axis, right? So let's say I want to put numbers in some of those locations. So this time I want to put ones in only on matrix 3, and I'm going to keep the other ones. I want to keep 1 and 2 and 0. Then I'm going to fill this one in the third matrix with just 1. So it's similar to what you do in 2 dimensions, but you got to keep track of the third extra term. So all the rows, all the columns of the third matrix now, I'm going to have 1. Oh, because I use capital. Now you can see that, the zeros remain on the first matrix, remain on the second matrix, and now the third matrix has been replaced all by ones. Let's say, clear this again, start from scratch with all zeros, and this time I want to put ones in just the matrix, the first matrix. The first one. Sorry about that. Okay, so just the first matrix. Okay. That you can see now, the third matrix has 0, the second matrix has 0, and all the ones are in matrix number 1. Okay. I think you get a picture now, right? If I want to do it with the second matrix only, I'm going to reset everything again. This time I only want to do it with the second matrix. There we go. Second matrix only. And now, looking again at my results, you can see the third matrix has 0, second matrix has 1, but the first matrix has 0 also. Okay. Right. So that's how you can manipulate how we put numbers in the particular locations for each of the matrices. Let's say now I want to have ones only on matrices 1 and 2. So matrix 3 is going to remain 0. The matrices 1 and 2 will have 1s. We reset back to this matrix 6. And now I'm going to have, again, all rows and columns. Then now I'm going to use matrix 1 and 2. And I want to assign or put ones into just those two matrices. So you can see I have 1 in 1, matrix 2, and matrix 3 remains 0. Okay. Couple more examples just to make sure you're getting a picture. Okay. Reset back to the zeros, my original set of matrices. And now I'm going to put ones in matrices 2 and 3. 2 and 3. So matrix 1 will remain with 0, right? So again, this time I'm going to have 2 and 3. See now that matrix 3 has 1s, matrix 2 has 1s, matrix 1 remains with 0, right? So that's one way that you can start putting values. The reason we're doing this is because what we're going to see later in the manipulation of color images is that, like I said, each pixel will represent a color. And the pixel has 3 dimensions, 3 values, all red, blue. And so if we allow one of those matrices to represent a color, matrix 1 red, matrix 2 green, matrix 3 blue, then by manipulating the numbers from 0 to 1, we can then create different colors. You'll see that in the next slide. But the main thing is that you know that by putting numbers in this individual location and combining the 3 matrices coordinates, you can get different numbers. So let's say now I want to add again, let me reset to my original matrix of zeros, and I'm going to put ones in the locations from row 2 to 4 and columns 2 to 4, but only in this matrix, right? So the other two matrices, I'm going to keep it at 0, but I only want to put information on matrix 3, and I want to put ones from row 2 to 4 and from columns when they intersect columns 2 and 4. So let's do that. I do 2 to 4, 2 to 4, and the column of the rows, so intersecting. And I'm only going to do matrix 3, and I will only want to put ones in that location. So as you can see, there's only ones in these locations, right? The other matrices are untouched, zeros, right? So I want to affect all the matrices, and say now, it doesn't matter if I reset or not, I'm going to change it to another number. So I'm going to make all the matrices equals to one number. In this case, I want to have the matrix's values to be 5. So as you can see now, all the matrices are now being replaced with the value of 5 by using this command. All right, so the idea I want you to get out of this is that if we put numbers, in this case, the numbers will be from 0 to 1 to color images. By putting numbers from 0 to 1, anything from 0 to 1 between, and each of these locations, then the program will interpret the combination of those numbers, 3 coordinates, as 1 pixel, and that pixel will then be represented by a certain color. Okay, so keep that in mind, and we'll use that information in the next slide. Okay, so I think this is a good stopping point. We'll continue with this in the next lecture. We'll use the information we just described here in this example to then manipulate actual colors with in the RGB spectrum.